Hello friends, today's question. A piece of wire is bent in the shape of parabola. Equation is given as y is equal to kx square. Y is the axis vertical with a bead of mass m on it. A bead can slide on the wire without friction. It stays at the lowest point of the parabola when the wire is at rest. The wire is now accelerated parallel to the x-axis with a constant acceleration a. The distance of new equilibrium position from the y-axis of the bead, where bead can stay at rest with respect to the wire. So let's draw the diagram. So you can say this is our x-axis and this is y-axis, and we have a parabola like this. Now this parabola is going to move with a constant acceleration a to the positive x-axis. Okay. And initially the bead is at the lowest point, it means here, but as it parabola starts to move towards right side, the bead will change its position towards the negative of x-axis, and let us suppose this is its new position where it is in equilibrium. Okay. So here there will be normal acting like this, perpendicular to the contact surface. This normal can be divided into two components, and we assume that this angle is theta. So we get this as n cos of theta, and this is our n sin of theta. And there will be also pseudo force which will be acting on the bead, and that will be ma. Okay. So this is our pseudo force. So this is the original position of bead, and this is, you can say, new equilibrium position. New equilibrium position. So now as the bead is in equilibrium and in the downward direction, we are going to have a mg. So we can say as the bead is in equilibrium, forces acting on the bead will also be in equilibrium. So let us balance the vertical forces and the horizontal forces. So from here we can say forces on the bead in horizontal direction in the horizontal direction we have two forces, one is n sine theta and another is the pseudo force. So we can say that our n sine of theta will be equal to ma. Let's call equation number 1. And in vertical direction, we have n cos theta and mg. and cos theta is equal to mg. Let us see equation number 2. So dividing equation 1 by 2. Dividing equation 1 by 2, we get n sin theta divided by n cos theta is equal to ma divided by mg. N and mm cancels out. So from here we can say we get tangent of theta is equal to a upon g. Let this be equation number 3. Now the given equation of parabola is y is equal to kx square. Given equation of parabola is y is equal to kx square. Now differentiating this equation with respect to x, differentiating equation with respect to x, let us call this equation number 4. Equation 4 with respect to x, we get dy by dx is equal to 2kx. This is equation number 5. Now if you compare equation number 3 and 5, tangent of theta is also representative of slope, and dy by dx is also representative of slope. Comparing equation 3 and 5, tan of theta is representation of slope, and dy by dx is also representation of slope. So from here we can say that our 2kx will be equal to a by g, and the displacement x will be equal to, we get a divided by 2kg. So this is the distance of new equilibrium along x-axis. So we can say this is the distance of new equilibrium position from y-axis. Okay. So this is the distance of the equilibrium from the new equilibrium, rather from the y-axis. Okay. So it means we can, if we want to draw, we can also represent it with help of figure. This is our x-axis and this is y-axis. So now equilibrium, the parabola will be shifted something like this. Okay. And this will be, suppose, new position, and this distance will be given as x. So this is the new position of the equilibrium if it is moving towards right side with acceleration a. And this x is given as a divided by 2k by g. You can say this is new position of equilibrium. And remember that this is moving with the constant acceleration. Okay, so this position will be, you can say this is our bead. Sorry, this is not y, but this is y. So this completes the question. Thank you.